Being an experimental physics researcher, he has mostly focused on developing and teaching labs to BTech students. He'll be sharing the innovations used to elicit student motivation and interest in both offline and online mode of students' lab experience. So, with this brief introduction, I would like to hand over to Professor Pradeep Sarin.
So, thanks, Dr. Professor Sarin, for the introduction. I will share, I just prepared a couple of slides since we are already running behind time, just to outline what we have done. Let me upload this. Yeah. So I will also be showing some things on the video in parallel. Uh, so you'll have to, I guess, split your attention between this, what is on the slides, which are just sort of bullet points. But let me first highlight what are the important things that I feel, what are the important problems that I feel we face in the IIT system. This slide is right now it's in the context of the ongoing students being stuck at home. So in that scenario, the biggest problem has been how to give students a hands-on learning experience while they're stuck at home. And this is an important problem because an essential differentiating component of the IIT experience, why our students are valued so much outside, is the hands-on learning. So even in the teaching labs, the students get to work on equipment that is almost research grade. I've been to colleges outside where even the research labs don't have such good equipment that our students can use in the teaching labs. And of course, beyond this, they also have plenty of opportunities to tinker with stuff in their research projects and in extracurricular activities like TechFest and so on. So the context of our solution is that for the engineering physics students, I have been teaching 4 labs in electronics. When I was a student, these were taken jointly between the electrical engineering department and the physics department. But now, for logistical reasons, they have sort of been separated. So I have been teaching these 4 labs, spanning pretty much all the domains of electronics, from transistor based to op amps to digital electronics and then to microprocessors. So our solution for the current scenario has been to put together little kits that contain all the necessary components required to perform the lab assignments at home. And these kits were sent to the students just before the start of the semester. I will show you now on video. I will show you what the kit looks like and what are its main components. Let me see if I can pull this up. So it just comes in a box like this. The vendor actually last semester they actually put a nice IIT logo on the box as well. This semester they just sort of sent it in a brown box. So it has a couple of breadboards. It has the multimeter, all the required sort of passive components and the transistors, the resistors. We went through a very careful sort of process of choosing which components are required. So these are the digital ICs that will be required for the digital electronics labs, the wires and so on and so forth. The most crucial component, as in any measurement system, is the measurement device as well. So we were able to find this little pocket oscilloscope. I'll show that to you. And so this is just handheld. It actually comes in a kit format. So in principle, the students should be able to assemble this completely on their own, but we cannot assume that they have the soldering tools and so on at home. So we bought it in pre-assembled form. And the nice thing about this is that it runs off of a 9-volt power supply. And just for a student to be able to sit at home, and I'm not sure if you can see the screen. Right now the screen is showing a flat line. So the oscilloscope itself produces a 1 kilohertz square wave reference waveform on the board. So when I probe that, I see a square wave. It's probably not visible very clearly on your on the video screen. I can see it. I'm not sure how clearly it is visible to you. So this is an amazing experience for students in the middle of sitting through hours and hours of video lectures to be able to just hold something in their hands and do some stuff with it. And finally, our students are basically, these are sort of second year, third year students. They're 18, 19-year-old students. They're very active physically. They like doing stuff with their hands, most of them at least. So one of the I have put the last line because there are a couple of, as it turned out when I was thinking about how to put these kits together, there are a couple of socioeconomic considerations that I had to take into account when deciding what goes into such a kit. So one of those things, for example, is that if I imagine a student sitting at home, it is not, I cannot take it as a given that they have many plug points and in which to plug in all these things. And of course, in the lab, as you know, if you visited the labs on the benchtop, we have an oscilloscope, we have a function generator, we have multimeters and so on, and they're all plugged in permanently onto the sockets on the tabletop. Now, if you think about a student sitting at home, they will have their laptop plugged into the wall plug point. Typically, they'll also need to keep their phones charged. And if you look at the average home wall plug, it is not likely to have too many plug points. So fine, you put extension cords, but the extension cord may not reach near where the student's desk or sitting place is. So thinking about all of these things, this kit has been designed entirely to run on a single 9-volt DC adapter, which if the one that we send breaks, the student can go out to the market and buy a new one. And the circuits that they build on their breadboard run off of 9-volt batteries. So the DSO requires somewhat higher current. So the oscilloscope requires its own 9-volt adapter. But circuits run on the basically just the standard 9-volt battery. That turned out to be actually a big headache for us to ship because typically couriers don't ship batteries. So we had to do a lot of legwork to somehow get these standard 9-volt batteries to the students or have them buy the batteries often run out of charge as the experiments progress. So they have to keep going out to buy new batteries, etc. So these are some of the things that I found I have to think about in detail. Right? I cannot just assume that what is available on campus is the same as what is available to the student at home. So that is basically the main intervention that I did for these labs. We have done it for 3 semesters now. We did it in autumn of 2020, spring of this year, and now we're doing it again in the autumn in the current semester for second year and third year students. So that's sort of the practical aspects of it, and the ingredients required. This is sort of the more crucial aspects of the pedagogy that is needed. The change in pedagogy this is needed for to make this successful. And this actually applies to. I was doing this even for the earlier times when the students were on campus. So these labs run with no lab manual. The students are not told what to do. Because as researchers, we are not told what to do. We know sort of the general techniques of how things are done, how certain instruments are used, etc. But when I work on a research experiment, a priori, I do not know exactly how to solve the problem. That's the fun of doing a research problem. But you actually, as you go along, you develop the procedure, how to do the experiment to get a successful result. So we try to, at least my personal aim is to try and impart this crucial skill to the students as they're learning in the labs. So there is never any lab manual in the labs that I teach. And in the current scenario, since we have a little more time as the students are online, the typical timetable I have set up for the course is that it's not a 3-hour lab session. So on Mondays, for example, on Mondays at 1 p.m. I post a lab assignment. The students have a couple of hours to look at the assignment statement in detail, and then at 2:30 we'll have a live video session with the students where the main theoretical ingredients which the students may have learned in an earlier semester but would have forgotten, or they may have learned it in a very theoretical fashion. So now I sort of discuss it as applicable to the problem that they're facing. That has to be, like, a circuit has to be built, certain measurements have to be done. A typical example of such measurement is, at least we have been able to design an experiment that creates, I'm not sure how many of you would be familiar with the concept of a lock-in amplifier. A lock-in amplifier is an amplifier that basically amplifies signal at a particular frequency and rejects signals at all other frequencies. So when you're sitting in a room, the tube light, because it's running from 230 volts AC, it actually flickers at 50 hertz. So AC line frequency is 50 hertz. It's a very, very small effect. My eyes can perceive it, so I therefore never use tube lights anywhere where I sit. But in principle, it is possible even on a breadboard using a simple photodiode to get enough accuracy to measure the amplitude of this flickering thing. So this requires, of course, understanding the concept of what are the ingredients that go into building a lock-in amplifier. So that's what we discuss for about an hour, hour and a half. I will breakout rooms with TAs during that live session. And then Monday, Tuesday, Wednesday, the students have to go off on their own and they work and discuss. Typically, mostly in the night time. So the format of the discussions I have enforced is basically everything has to be done on Moodle, not through WhatsApp groups, of which I have no control. So the way we do it is basically I create a Moodle forum for each lab assignment. And in Moodle, it's possible to set up the forum such that each post gets marks. In Moodle terminology, it's called ratings. So all the TAs can rate all the posts. So which means basically a student has an incentive to make a post. They know that if they post a doubt, even if they post a doubt or they clarify somebody else's doubt, they're going to get marks for that post. So this is very bandwidth conserving in the sense that a student does not need to have a high bandwidth internet connection. These are just text posts. Sometimes they may want to add an image or some circuit diagram to the post. And so these Moodle forums are basically moderated by TAs. If I see a post that is not relevant, I just simply delete it and warn the student not to post something like that again, and so on and so forth. I can share with you an example of such a discussion the typical example of such a discussion that happens. Let me see if I can switch to sharing something else. Oh, it's not this. Wait, I'm not sure. Can you see this web page of my Moodle course?
Yes, Pradeep.
Okay, so this is an example of a discussion forum where this was relevant to the microprocessor lab. So you can see the kind of posts that, well, this post was not created. So people, some of the brighter students end up actually posting research papers because they have found something that is relevant to a particular point. So this post has gotten a rating of 8, and this post was not very good, so I gave a rating of. So people post have hastily drawn circuit diagrams and so on. And so for each lab assignment, basically there is a discussion forum. a lot of sort of active discussion going on about every topic that is discussed in every lab. So I found this very gratifying that students are actually, this shows that they're actually thinking about what they're doing. And they're able to sort of articulate what they're doing very well. Because a crucial aspect of doing scientific research, as you know, is being able to articulate your ideas precisely enough so that somebody else can understand what you're saying and be able to replicate that problem. So, sure. So now let me go back to the slide. Let's see. Yeah. So practically speaking, one of the things that I have found to make this forum discussion a successful process is that always the leading question has to be, and the instructor or TA has to ask some seed questions. So each discussion has to be seeded in some way. So typically after the class, I will ask a question, or I was discussing this thing in the class session, but what about this other idea that I did not have time to discuss? So do you guys have any thoughts or opinions on that? Because typically, even when you're teaching a live class, you will find that students are everybody is very hesitant to be the first person to speak up in class. There are very few very bright students sitting on the front benches who will always speak up first, and the people who are in the background will either sort of lose interest or will be too shy to speak up. So in this forum scenario, since they know that for every post that they make, they will get marks. So if I ask a question or if a TA asks a question, many people will chime in with ideas, saying that, oh, I think this is not right, or maybe this other idea is correct, etc. So that happens over 3 days, not over 3 hours as we do in a regular lab session. And on a Thursday at 1 p.m. Is the deadline to submit the lab assignment. So that's also done on Moodle. So the submission is in the format of, so lab assignment is put out as a Word document, and the way the students submit the assignment is they build the circuits. They have to take photos of the working circuit with with sort of their ID card in the photo frame. Prove that it's their own circuit that they've built, not a photo of somebody else's circuit. And that has to go into the lab assignment, and that is submitted on Moodle in PDF format. So I get a couple of hours to look at these submissions, and then I have a wrap-up session to summarize the concepts that were dealt with during the lab in greater depth. And often I take the opportunity to highlight some of the best solutions. So students like it a lot if their name showed up on screen that my solution was the best solution. So it's professor is speaking about it and so on. Because the students come up with such brilliant ideas which even I would not have thought about. So I put out the model solution for the TAs to assign marks, but in many cases, the students have come up with cleverer ideas to solve the same problem. So I try to highlight them on Thursday afternoons and then give some background for the upcoming next week's lab assignment. So this is all that I wanted to talk about. These are the same thing, this process I have described in these two slides is basically what is being done for this online mode. But we do the same thing when we are doing the labs in person also. It's just that the whole process is compressed into 3 hours. Essentially, it's one lab afternoon session. So in that case, basically we start at 1:30 or so, and we don't necessarily end at 5 o'clock. The lab slot is supposed to be 2 to 5. But typically the students end up working till 6:30, 7. So on the days that I have lab teaching, I tell my wife that I'm not going to be home before 8:30 because the students will be working. But once their mind gets caught up in a problem and they have the equipment in front of them, they know that if they change something, something is going to change on the oscilloscope screen. They refuse to let go until they fix the problem that they're having with this circuit. So in the online mode, we're actually having the luxury of expanding the process over 3 days, because it's not necessary that on Monday afternoon 2 to 5 the student will have electricity at home. There might be a power cut, there might be, on any of these 3 days, there might be a power cut, etc. So I have to basically give them some expanded timeline to do the lab session. So now I'm open to any questions that you would like to ask me, or ideas that you have to improve our process.
Are there any questions for Mr. Pradeep? I have a question, Pradeep. I think very exciting idea of sending a kit to them, and so just a curiosity. You have oscilloscope, so they can view the result. What about signal generation?
So that is actually, that's a good point. I didn't mention it when. So the first experiment they do in the basic electronics lab is actually to build a function generator on the breadboard.
I see.
And it would have been, I could have looked around and found a function generator unit also, an equivalent function, but then it's just a black box. Whereas with just an IC 555, which many of them have actually used in the 10 standard hobby kit. Like many of our students have done hobby electronics before, so they know how to make a square wave form.
Oh, I
The
see.
first lab experiment in the basic electronics lab is actually to make the function generator, to shape its output to take a square wave and convert it into a sine or at least a sawtooth waveform, so that they can, and then we make sure that they're able to build that circuit solidly enough. We tell them that we're going to be using it for the remaining 4 laboratories. So that's how they have their first experience to build a solid circuit on a breadboard. Otherwise, beginners will typically just hang wires here and there, and then they're able to get the result and move on to the next lab. But we tell them that, look, you're going to use this circuit for the next lab, and then the lab after that, and so on and so forth. So just by making sure that they get this one circuit completely solid, both in their mind and also how to build a circuit on the breadboard such that it is durable.
Okay, great.
So I think the last point on this slide, the wrap-up session, to my mind, is sort of the crucial aspect of the pedagogy, because in general, I have found that students, you teach something during the course. Even I've taught theory courses as well, and you teach a lot of content during the course, and then there's a midterm exam, and then there's an end-sem exam. So now the midterm exam or the end-sem exam is usually a very traumatic experience. Like you study very hard and you try very hard to solve the exam in the 2 hours, 3 hours, and so on. And then right after that, it's like your brain tries to suppress that trauma. So you actually actively try to forget what you did. This has been my experience as a student. So even like what was done during the mid-sem, by the time the end-sem comes around, the student has mostly forgotten what was done in the mid-sem. So I find this aspect of going over again what you have just finished doing, that sort of fixes the concepts in the student's mind much more rigidly, because they have finished it, so they can't do any more. But now that they get to discuss it again in more gory detail, then they realize, oh, this is what I did wrong, or this is what I could have done better, and so on.
Okay.
Who will send? Amazon will send kits, or IIT will send?
So we found a vendor, and we actually, so the passive components are just regular resistors, capacitors. We found a small-time vendor that is actually based in Bangalore, who essentially sources all this material in bulk from China. And he was willing to work with us to put together, to assemble all the components into a nice box. The first time we did this, in the summer last year, summer of 2020. We actually did all the hard work on our own. So we have our teaching lab is well stocked with all these components except the oscilloscope. So our staff actually spent a month putting together 50 boxes one by one with all the required components. And by the time winter came around, we didn't have enough time and we found a vendor who was willing to do it for us at some. The entire kit is not very expensive, including the oscilloscope. It comes out to be something like 2,200 rupees. So for a class of 55 students, the total cost is something like 2.45 lakhs. So it still fits within the 2.5 lakhs limit. So it's easy to purchase it as such, as a bulk thing. And so basically the vendor ships them. We send the vendor a spreadsheet with all the students' addresses. And then the vendor sends it directly to the students. We have students as far apart. I think the problematic shipping cases was there's one student from in the current class from Arunachal Pradesh. There was one student last semester who's from Leh. And there were two students from Gadchiroli. For the Gadchiroli students, which is Naxalite, I had to send 3 kits. So only the 3rd kit reached. The first 2 kits were just lost in transit somewhere. So these practical logistics issues are there, but they're all solvable. And now, of course, the vendor is very happy because now he's getting orders for the same types of kits from various other colleges. I think he supplied such kits to some NITs. I forget which other place. IIT Madras, somebody contacted me for similar idea. So I gave him the contact of this vendor. Maybe they've ordered it also.
Yeah, I think it's an excellent idea. It could be used even under normal semester. Why just because if students have something in their available to them and they can experiment, they will be more excited.
Yeah, we might have to, unfortunately, just because of logistics. So when I set up the lab, teaching lab, we had budgeted for 60 students. That time our department BTech batch was 35 students. So assuming sort of a ballooning of numbers, there are 60 sitting places. Each sitting spot has a complete suite of instruments. These are not setups. These are not preset experiments. Each desk has just basically the basic tools of the trade: an oscilloscope, a function generator, a multimeter, and a laptop to look up data sheets and so on and so forth. But we had set up 60 such places, and now this year the batch size is 65. And probably when the students come back, there will be distancing requirements. The students cannot sit too close to each other and so on. So we might actually have to do this even when the students are physically on campus.